Hey everybody, good evening. The purpose of this video is to introduce you all to my latest project, which is titled Article Analytics Platform. Now, the idea behind developing this particular project was to explore the various facets in the world of natural language processing. As you know that in the realm of machine learning and deep learning, the broad use cases of these two supercharged exponentially growing technologies is across two distinct domains. The first is computer vision, that usually deals with object identification, where models like convolutional neural networks are extremely pertinent. On the other hand, the other applications of technologies like machine learning and deep learning, or rather fields of study like machine learning and deep learning, is natural language processing. Over the last few years, the domain of natural language processing has seen insurmountable growth that precipitated quite well in the year 2023 with the advent of ChatGPT. And since then, this domain is continuously growing and it's con- it's constantly opening avenues for very interesting research. So I wanted to create a project using a dataset that I found online, which consisted of articles published in the New York Times over the course of multiple years. Now remember that this project is going to come in two parts. In this specific video, I'll be talking more about the techniques that I used and the different methods that I leveraged over a tiny little corpus of dataset that consists of 500,000 records. The dataset, albeit, has 21 million records. The second part of this particular project will be handling large amounts of data and scaling the project rather to handle large amounts of data and actually deploying this particular application in a cloud environment. So I would request you all to stay tuned for that. But till then, I would like to introduce sort of the broader framework of the project, introduce you to the platform that I have developed, and give you a fundamental idea of the evolution of natural language processing over the years and how this particular domain has been shaped through multiple epochs of very interesting innovation. So let's get started with me introducing you all to the platform itself. So the main idea or the central idea behind this particular project was to create a platform that would ingest an, insur- an insurmountable amount of text data that is present in the form of news articles. And once this particular platform ingests that data, it pre-processes and cleans the data and then uses interesting models that perform a whole host of functions. So, for example, it can detect the various topics and themes which are part of these news articles. It can construe the sentiment that are embedded in those articles. Third, if a user wants to get article recommendations based on a certain theme that he wants to explore, then there is semantic search analysis where the user can enter specific keywords and then the platform is going to return to him or her specific articles that he or she can explore. And fourth is a very specific use case for which I have leveraged two different large language models, in particular GPT-4 Omni and Gemini. Fundamentally, the use case is that for each specific year, I'm construing books from the book section in the New York Times. I'm construing different book names and authors and how frequently those authors were discussed in the pages of the New York Times for that specific year. We are basically using the pydantic framework to extract the name of the author and the book and the frequency of the number of times that author was discussed in the New York Times articles. And we are using Gemini as a judge to make sure that the information that we're extracting is not fabricated and we are getting the accurate information from these articles. So before I actually delve into further details of uh, the various applications that this particular platform uh, engages in, let me go ahead and quickly give you a brief overview of how NLP as a domain has sort of evolved over the last few years, or rather, I would say the last few decades. So, when NLP was just a very inchoate, burgeoning field of research, The first few techniques that were primarily used to represent words in a specific form that is interpretable to machines involved techniques like one-hot encoding, techniques like bag of words, and things like term frequency and inverse document frequency. Those were the first few techniques that were primarily used to represent words in a form that could be interpreted by algorithms and by models. Now, these approaches were kind of a good starting point, but one of the main drawbacks of these approaches was the lack of semantic meaning that these methods gave to these words. There was no innate meaning that one could express through these specific methods. And that is one of the drawbacks that NLP researchers had to push against over the years. And that eventually led to the second epoch of innovation in natural language processing, where we moved away from this kind of numeric arbitrary representation of words to a much more semantic form of representation. Now, this semantic form of representation involves techniques like word-to-vec and glove. And broadly, now we are getting into a realm of representing words through embeddings. Now, essentially, what embeddings are, they are these vector-based representations of words. And what embeddings fundamentally try to do is they try to represent a word in a way where it represents a semantic meaning of that word in the context of a particular sentence. Now, one way in which I can articulate the way we understand language is we basically study words within the context of a broader sentence. And that aperture kind of grows, and eventually the broadening of the aperture leads from a word to a sentence to a paragraph to a page, the page to a chapter, and a chapter to a book. So you read the chapter in the context of a book, you read a paragraph in the context of a chapter, you read a sentence in the context of a paragraph, and you understand the word within the context of a sentence. That is really how we try and understand word meanings in our own heads, and we try to construe a coherent story in our minds. We contextually broaden the aperture and we understand each of these concepts first in an isolated way and then within the broader context. So, having said that, what these word embeddings do is that they represent the word in a way where they put this particular word within the context of a sentence to give it specific meaning. And now, having said that, one of the obstacles that we often encountered with representations like glove and word-to-vec is the fact that the representations really never changed. These were static representations. But sometimes the same word can be written in two different sentences and can portray two completely different meanings. I'll give you a very interesting example of that. So, for example, the word bank can really mean two things. One, if I am sitting near the bank of a river, or I'm withdrawing cash from a bank. Now, in this particular case, as you can see, depending on how I use the word bank, the meaning of the sentence changes. And therefore, we had to move from static representation through word embeddings to a much more dynamic representation where the embedding changes depending on how the word is used in a specific sentence. This is where we delve into the BERT model, which is a bidirectional encoding model that uses transformers. And in the process of encoding, it uses a technique called self-attention mechanism. Now, this self-attention mechanism is responsible for creating that dynamic embeddings because it changes the representation based on the way in which a particular word is being used in the context of a sentence. Now, having said that, we saw the evolution of BERT into bidirectional BERT, and since then, we have this kind of broader and much more advanced form of representation where now we can put words within a particular sentence that portray a specific meaning. And this dynamic representation fundamentally allows for the words to have malleable representations that change based on the way in which they are used in a specific sentence. So just to give a very brief recap so that we are on the same page, the NLP revolution started off with very arbitrary techniques that would really deal with frequency of words bereft of any semantic meaning. Techniques like one-hot encoding, techniques like bag of words, and techniques like TF-IDF gave a very good start to word representation, but did not really move the needle. After that, we come to a much more sophisticated form of representation like word2vec and glove. Now, these models fundamentally uh, represented the word in the form of vector embeddings that portrayed some form of semantic meaning that the word has within the context of a sentence. However, we still wanted much more flexibility with respect to the way in which these words are used in specific sentences, and that was sufficed by models like BERT that uses self-attention mechanism. So that is sort of the broad strokes overall general history of how NLP has evolved over the years. Now, there is a wonderful article actually that is written in Medium. You all can check out this specific article. It delves into all of the techniques that we have discussed, and it kind of gives you a very good overview of the history of natural language processing. Now, back to our project. So we have this particular platform that we have developed, and essentially, as I mentioned to you, we are basically trying to incorporate multiple facets of NLP research, and we are trying to demonstrate as many interesting examples as we can. Now, one of the very interesting applications of natural language processing, and it's kind of a subset of NLP, is topic modeling. Now, essentially, what topic modeling is fundamentally in the most parsimonious form. If I have to describe what topic modeling is basically if I have a pretty wide and pretty significant corpus of documents, and I want to sort of construe what are some of the broad topics that are part of this particular corpus. In those specific conditions and in those specific situations, I can use topic modeling. Now, as you can see, there are two distinct approaches to topic modeling. Now, this will make a lot of sense right now because this is also fundamentally a good a good extrapolation of the difference that we saw in the BERT-based embedding approach in natural language processing that fundamentally represented words. So the BERT-based approach used vector word embeddings versus a more frequency-based approach like TF-IDF or bag of words. Similarly, you have two different approaches here in topic modeling. The first approach is LDA. Now, LDA is a very popular method that fundamentally takes specific themes which are part of a particular document corpus, and through frequency, it basically tries to form these clusters. And through these clusters, it basically tries to construe what were the main topics that were discussed in comparison to something like a BERT topic that fundamentally uses a much more advanced technique using hierarchical clustering and BERT representations of topics to find similar topics and then construe what were the broad topics that were discussed. So in a very similar vein, LDA and BERT kind of are two broad techniques used for topic modeling, and we primarily use this to sort of construe in a given year for a particular section what were some of the most repetitive topics that were discussed. You will see an example of that very soon, but let me move to some of the other features that our platform tries to incorporate. One of the other features is sentiment analysis, where we kind of construe what what was sort of the broader sentiment of the articles that were written in a specific year for a specific section. Now, depending here on which specific section that we were looking at, we used a whole host of different sentiment analysis models. Primarily, most of them are BERT-based, but they are fine-tuned models that are available on GitHub, and they are fine-tuned on specific kinds of data. So you have so very interesting examples were sort of FinBERT. So I use this to basically gauge the sentiment of the business section or the stock market section. And PoliBERT is primarily used by political pundits to discuss the broader in political discourses. So something like local US news, you can really construe the sentiment of those specific sections using PoliBERT. And then some general BERT based models like Distal, RoBERTa, and RoBERTa General. So these were some of the models that I used for sentiment analysis. And then we kind of also have a section in our platform where we, as I mentioned to you, another interesting analysis that we are doing is article recommendations. So based on a specific requirement of the user, we are trying to recommend the user specific articles. Now, this is where we also sort of introduce a very interesting concept, or rather explore a very interesting concept of information retrieval. So there are two distinct approaches to information retrieval. We can either focus a lot on the keyword search. So it means that when we are basically trying to construe what are the similar articles that resemble the keyword that the user entered, we can go just by the semantics, or sorry, we can either go just by the words, or we can go just by the semantic meaning, or we can have a hybrid approach where we combine the importance and the relevance of the words and the relevance of the semantic meaning behind the words. So we are basically incorporating a hybrid research that gives uh, kind of an egalitarian weight to both the keyword and the semantic meaning. And that is something that I will show you very soon. At the same time, then we kind of, so this is something that I wanted to show you. So we are using a hybrid technique where we are using both the semantic score and the keyword similarity score, and we are basically using this alpha parameter to basically give sort of priority to one over the other. Now, if it's extremely to the right, it becomes very semantics focused. If it's extremely to the left, it becomes very keywords focused. And finally, we have this final feature where we look at an article that is published in the book section, and we extract the book title and the name of the author. And in this particular section, in this particular approach, we use this kind of a pipeline where we are extracting the information from an article using GPT 3.5, and we are basically verifying the information that is extracted using Gemini 2.0. So this is kind of an LLM as a judge kind of an approach that we are taking. So this is the overall description of the project. Now, let me quickly go to the project itself and actually show you some very interesting features. So I go to visualization, and let's just start off with just looking at some interesting visualizations from some of these sections. So if I take technology and I use, so we have LDA and we have BERTopic. So we are using both of these models for topic visualization. And let's just say we take 3 topics and I generate word cloud. Now, word clouds are a very interesting way to look at various different themes that were discussed in a bunch of articles. As you will see, once the word clouds are generated, it will show you what are sort of the different themes that were discussed in the year 2002 in the technology section. And we are basically restricting it to 3 topics at this given point in time. So we will now just sit back, relax, and wait till we get the results. Now, this is something that the analysis generated. So as you can see, uh, top keywords are online, web, computer, art, and state. In the second topic, we have news, watch, digital, photo, and music. So word clouds are a very interesting way to sort of visualize what are some of the topics that are getting discussed more frequently than others. And we kept the number of topics to 3. So this number basically tells you or it tells the model how many top topics that we want to demonstrate or we want to show. Now we go to topic modeling itself, and we look at topic discovery for some of the sections. Now it's very similar to kind of what we saw in topic visualization, but this is just another way of looking at it. So we go to sports, we keep it to BERT topic, and we go for 3 topics again. Let's run the topic modeling BERT topic model, and let us see what this particular model gives us. So again, we are doing it for the year 2003 for sports section, and we are using BERT topic to give us the prominent topics or the top prominent topics or the top 3 prominent topics that were discussed in this particular year. Again, it's worth telling you that I'm showing this analysis basically on a subset of the data. So I have chosen 500,000 records just for the sake of this demonstration. I will be curating a different video and I'll be posting a different video to basically demonstrate to you how do we handle data at scale. And we'll be delving into multiple interesting techniques, that we can leverage in a cloud platform to actually handle, you know, a fire hose of incoming data. But some of the topics here are baseball, sports, Yankees, Mets, hockey, 2950, pro football, basketball, college news. So these are some of the discovered topics that were discussed in the year 2003 in the sports section. Then we come to the article search. Now, as I told you, this is a section where the user gives an input to our platform, depending on what the user wants to read. And we are using a hybrid approach that combines keywords and semantics to basically recommend articles to the user. So let's just say I would like to, get some articles on the New York Yankees. And I would like 3 results again. People search the articles. Let's see what it gives us. We are waiting for it to show us. It's worth mentioning again that it will be very interesting to see how we handle 21 million records and what are some of the interesting insights that we get. Because this particular data set was very, very interesting because it had so many different articles. And if you kind of delve into the different themes of these different sections that are published in the New York Times, then it will be a very interesting use case to sort of delineate and decipher. So I cannot wait to actually take this project and actually scale it up to 21 million records, because there are so many different ideas that you can play around with this kind of a data set. We're still waiting for the model to return us, and there you go. So these are the 3 articles that were that this particular search returned. So one is in the opinion section. It had a hybrid score of 87.52. The New York City in victory or defeat kicker. The second one. So the first one was letters New York City in Vic. The snippet shows New York forecast. Again, another opinion piece. And the third one is in the sports section, New York Sailors winners symbolism. So these are the 3 different articles that this particular search returned to us. And this is using this particular, sort of bar. You can control how much, to what degree you want to explore meaning versus keyword. Now we come to sentiment analysis. Let's just say I take the year 2003 and I go to business day, and let's just look at the report and what the report shows us for sentiment analysis. This is going to be an interesting one. We will patiently wait as the model processes the data and returns us interesting results. The New York Times, by the way, has a whole host of very interesting sections from sports to opinion pieces to uh, local news. So, whatever, if you are a consumer of the New York Times, or if there are specific, prolific writers that you read on a day-to-day basis, this is a very interesting platform that can give a sneak peek of their writing over the years, especially if the writers are, extremely well-renowned, prolific, and have been working in the publication for over a decade or two. Like someone like Thomas Friedman, it would be interesting to see how what they were writing about years ago versus what they're writing about now, and how their opinions have kind of vacillated and they ebbed and flow on these multiple topics over the years. We're still waiting for the report to load, and I would love to know from you guys, what do you think about this particular project? What are some of the other interesting features that you would like me to add to this particular platform? And yeah, this will be a very, very interesting development as we still wait for our report to be generated. It's taking some time. All right. So here we have the results. So as you can see, the FinBERT is showing a 12% positive, 27% negative, and 61% neutral. On the other hand, FineBERT tone is heavily biased towards neutral. I have to say 90% it's showing neutral, whereas it's showing 6% positive and 4% negative. And then we have distal RoBERTa that is gone for 46% neutral, 37% positive, and 17% negative. So as you can see, there is a conflict between FinBERT and distal RoBERTa, which is very, very interesting. So in total, it analyzed 15,411 articles. And in the meantime, while we are discussing this, I would like to also take the time to remind you all that this is my GitHub repository. This is where I have all the necessary code for this particular application. And finally, we go to an example of book uh, extraction. So this is kind of what I was showing to you all. You know, the extraction that we did with respect to the writers that were being discussed in a particular year. So these are the top authors of 2004. We have Dan Brown, Karen J. Fowler, Arthur Agatsson, Nicholas Sparks, and yep. So this, I actually ran this before sort of starting the video because I knew this is going to take some time. But you get the gist, that you get the idea that you choose the year, the section is going to be books, and we are extracting the name of the author, and we are basically demonstrating in that particular year what were the top authors that were discussed. And so this would sum up this particular video, and I would see you all very shortly in the next video where I will be showing you how I was able to scale this particular application and deploy this platform on cloud. I thank you all for listening to me, and I would love to hear from you all. What do you think about this? Give me feedback, give me ideas. Thank you so much for your time today.